One of the most important things you could do in your home and your business is to change all your incandescent lights out from the 75, 100 to 75 to 60, 40 watts down to LED. What we had done in the past is change the incandescents to the fluorescent lights, but that was about 50-55% efficient. Now you could change it to down to 11 watt, the 75 watt to LED. And LED bulbs are going to be the wave of the future, and we're going to change everything to LED. As you can see, we took this off, the old fluorescent. Now we have saved 85%. Then you do motion sensors that you could turn off and turn on, personal sensors, and either heat sensitive or motion sensitive, so when you're not in the room, it'll be totally off. The only way you could get a house to be net zero is not only to reduce the kilowatt hours but also the BTU. We have done it through conservation in this building. Now what we need is one of the forms of renewable alternative fuel, and one is the solar hot water system. So we have the solar hot water system that takes care of for a little bit of heat that we need, and also for the hot water. As you could see, the house is built with a 20-inch wall on down the cellar. You have 12-inch block with silica sand, clean fill sand. You got the 4-inch freezer panel and a 4-inch Pennsylvania stone. And then you have the garage door that is 4-inch thick. That's R34 insulation. Most garage doors are either 1 or 1.5 inches, maximum R10. And also, not only it's insulated all the way down, but it's also insulated underneath the garage with 4-inch R40 insulation panels. So all 6 sides of the building, like a thermos jug, it's super insulated. Well, we chose this beautiful lot overlooking the whole Normanskill Valley, facing south toward the Catskill Mountain and facing west toward the Helderbergs, because we wanted to have a beautiful southern exposure to build a house on. So this is due south, and what we did was we put the passive solar home right here, and as you can see, we have the solar greenhouse right here. These are 1-inch thick low E argon gas filled glass. Back in 1981 we did this, and we also have, as you can see, the panel that go below ground. We had a heat sink underneath it. Okay, the panel's on the ground and it goes below. And what we have done is that we have an eave extension here. As you can see now, this eave extension is 2 foot and not bringing the sun into the greenhouse. Well, these are the window quilts. During the winter, these window quilts are put down at night, so the E-rate, all the heat that we have captured in the heat sink underneath here and brought into the house doesn't go out at night. Basically, the black body object irradiated out to the universe, the heat. So the weakest point of any passive solar home is your windows. And so that's what you need to have a way to stop the heat at night going back out. Also, when the heat comes in, excess heat comes in, heat rises. So when the heat rises, we have the grill here where the heat is brought down from the top with a fan all the way down into the cellar, into the heat sink downstairs. So we have the system. Also that filters, we have filtered in there, clean it. About 10 ton of fireplace. This is Pennsylvania stone from the cellar all the way up. This is an unbelievable mass. We have a hydro heater, copper tubings that go down to the hot water tank that we have an exchanger. We have a double exchanger. We have a solar hot water system that's outside there that provides the solar heat for us. But when there's overcast, you have a couple of days of cold, snowy weather, the sun is not out, we use a little bit of wood. We put the wood in here and then turn on the switch right here. We turn the switch on over here and it brings heat from the wood into the exchanger in the solar tank. So we have a double exchange. We have a bottom exchanger for solar, top for the hydro heater. This way we don't have to use any fossil fuel for heat and hot water. Yes, the other thing for cooling, one of the cooling designs we have for this house, when we put in the total foundation, we put around a tubing all the way down into the below, outside of the foundation, tubing for geothermal purposes. And we also have a fresh air that comes from the outside, underneath the ground, into the building, into the hydro heater opening, and also upstairs fireplace. So you don't use the oxygen and the air from inside the house, you use the air from the outside of the house. Okay, so not only we use that for during the winter for air coming in, but during the summer we have a flue that we open up. It's black, and the sun hitting that black object creates thermal heat currents, sucks the heat up and brings from down below cellar and below the earth, brings the cooling into the vents downstairs and upstairs. And that's how we bring some natural cooling into the building also, using the 55 degrees to 60 degree temperature of the earth for that purpose. And so the combination of all these three types of cooling and three types of heating systems makes it go net zero. That's it.